All right, hello, Algebra 2. This is the last lesson of Unit 5, Lesson 5.7, Dividing Complex Numbers. So today we're looking at simplifying quotients, which is just, division problem of complex numbers. And just to refresh our memory, we want to be able to reduce things and want to know when we can reduce and when we cannot reduce. So right here, 45 over 9. So I want to show you kind of a different way. We know that 45 divided by 9 is 5. We know the answer is 5. But what I'm going to do is I'm going to factor 45. Well, 45 breaks apart into factors of 9 times 5. So those are factors. And when we have common factors on top and bottom, common factors reduce. All right. So the 9 divided by 9 reduces to a 1, and we get 1 times 5, or 5. So that's what's happening when we look at how we reduce numbers. We're looking at common factors, and you're going to hear that phrase a lot. Common factors reduce to 1. So here, again, now we have 5x over x. Well, what happens there? Again, I'm going to factor 5x. Well, 5x is 5 times, x. Those are the factors of 5 and a factor of x. And so now we have, again, a common factor on top and bottom that reduces to 1. And so again, we get 5 times 1 is 5. So those x's cross out and reduce. So then the question is, does this reduce? Can I just cross out the 5s and say that it's 1 over x? Does that work? And no, it does not. Okay. What's the difference here? You'll notice that these factors are products, and that's the big key here. When things are written as a product, then when we can reduce things. But addition and subtraction ruin everything. So you can't reduce things across addition or subtraction. You can reduce when things are products, all right? So really important that you understand that. This does not reduce. No. Okay. We're going to talk more about that second semester, I think. Okay, so we're going to do some simplifying. So here, again, example 1, make sure you write down the directions. Reduce all fractions. Reduce if you can. All right, let's see what we've got here. So this is a fraction, and you'll notice that this is 4 times I. So it is a product, and that's really important. Since it's a product, 4 times I, the I divided by I reduces to a 1. And so we're left with a negative out in front, and 4 times 1 is 4. So this is a nice reduction there. Those i's cross out perfectly. All right, let's look at B. We have negative 4i over 5i. And again, this is a negative in front. This is 4 times I over 5 times I. And again, that common factor I divided by I reduces to 1. And so again, we're left with negative 4/5. Super. So sometimes these are really easy. So what is different about C and D? Well, C and D have i's in the denominator. And this goes back to radicals. Remember that I is the same as the square root of negative 1. So what we have here is we actually have a radical in the denominator. And remember from before when we were working with radicals, we weren't allowed to have that radical in the denominator. So I need to rationalize. You thought you were done with rationalizing, but no, never. Okay. So the nice thing is we can rationalize pretty easily just multiplying top and bottom by I. So that's really, really nice. And let's see. So we get I times 1 or 1I. You can just write I also. It's fine. In the denominator, we have negative 5 times I squared. I times I is I squared. And ding, 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 ding. What is I squared? I squared is negative 1. So we have now negative 5 times negative 1, which turns to positive 5. So we get I over 5 for a fully simplified answer. Okay. Same problem here. It's kind of weird negative out in front. I guess I'll leave them there. Oh wait, I'm not going to do that. I have again, we can't have an I in the denominator. It's a radical. We're not allowed to. So we're going to multiply top and bottom by I easily. This is the easy way. All right, so in my numerator, I'm just going to attach this negative to the 5. Pick a spot, top or bottom, doesn't matter. But I'm going to move it to the top because there's already a negative down here. So I have negative 5I in the numerator. And in the denominator, I have negative 2I times I is I squared. And again, you're going ding, 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 ding. That I squared is really negative 1. So we have negative 2 times negative 1. That's what that I squared really is. And of course, negative 2 times negative 1 turns into positive 2. So we get negative 5I over 2, which is a great answer. It would also be equivalent to say a negative out in front and 5I over 2 as an answer. So that is also equivalent as long as you don't have two negatives. All right. Let's try some more. So the difference here, what is different about all of these quotients? The denominator is key. Here, this denominator is a monomial. Mano y mano, one-on-one. There is one term here. Versus all of these others are binomials. Two terms, a negative 2 and a positive I. Here, 3 and a negative I is a binomial. And this is where you have to be very careful. Two terms, a 1 and a 3i. So monomials are easy to get rid of the radical, easy to rationalize. All I have to do is multiply top and bottom by I. Easy to rationalize. So I'm going to distribute my I. Negative 5 times I is negative 5i. And then negative 2I times I is negative 2I squared. The denominator becomes I squared. I times I is I squared. And again, those I squareds have special meaning. So I'm just going to go ahead and change it. So this becomes negative 5I. This is negative 2 times negative 1, which becomes positive 2. So you'll notice I just changed the sign. That's what happens. I squared is negative 1. So if you'll remember, this negative 1 is technically dividing each term. Negative 5i divided by negative 1 plus 2 divided by negative 1. And you can clean that up. Negative divided by negative becomes positive 5i, and 2 divided by negative 1 becomes negative 2. So this is a very clean answer. This is not incorrect, but it's not pretty either, is it? Negative 5 divided by negative 1 turns to positive 5, and 2 divided by negative 1 turns to negative 2. This is a better answer, I think. It's definitely more simple. All right, so monomials are easy to rationalize, but here with binomials, to rationalize, and again, we're rationalizing because there's a radical in the denominator. That I is a radical negative 1, so there's a radical there. Means to multiply by the conjugate. really important that you multiply by the conjugate. So we're going to change one sign. We're going to multiply, change the sign. So -2 minus I on top and bottom. So if it's a monomial, very easy. If it's a binomial, we have to multiply by the conjugate, okay, of the denominator, which changes the sign. Now we can distribute. So -5 times -2 is positive 10. -5 times -I is positive 5I. In the denominator, -2 times -2 is positive 4. The outside, -2 times -I is positive 2I. The inside, I times -2 is -2I. And last times last, I times -I is -I squared. So again, paying attention to that negative. So we have 10 plus 5I in the numerator. And look what happens in the denominator. Totally cleans up. Positive 2I and -2I is 0. And we get 4 -I squared. That's negative of -1. Negative times -1 becomes positive 1. And so we get 10 plus 5I, all divided by 5. This is where reducing is key. On IXL, we have to reduce. And so what is this 5 dividing? It's dividing both terms. So we have 10/5 plus 5I over 5. And those reduce. 10 divided by 5 is 2. 5I divided by 5 is I. So we get 10 divided by 5 is 2. And the 5's cancel out, just leaving I. 2 plus I cleans up a ton. So please, please, please divide and conquer to reduce. You'll always get it right if you do that. All right, let's look at this one. So again, we're going to multiply by the conjugate. So we're going to multiply by 3 plus I on top and bottom. I'm going to distribute my 7I. 7I times 3 is 21I. And 7I times I is positive 7I squared. So again, paying attention to that I squared changes the sign. Looking at the denominator, we're going to FOIL. First times first is 9. 3 times I is positive 3I. The inside, negative I times 3 is negative 3I. And last times last, negative I times positive I is negative I squared. So again, we have another I squared. So let's see what happens here. I squared is -1. So this is 7 times -1, which is -7, plus the 21I in the numerator. You'll notice I switched those around. And here in the denominator, lots of cleanup happening. Positive 3I and negative 3I goes away. And the 9 stays. But here we have minus -1. Minus a -1 becomes plus 1. So we get -7 plus 21I, all divided by 10. 9 plus 1 is 10. And those do not reduce. The 7 and the 10 don't reduce. The 21 and the 10 don't reduce. So I don't have to reduce that one. It is in lowest terms. And this is a great answer. It would also be equivalent to say -7/10 plus 21/10 I. This is an equivalent answer. And then trig, we like it this way. All right, last but not least, this is definitely the most complicated one here. Again, because of the binomial, we have to multiply by the conjugate, 1 minus 3I on top and bottom. All right, lots of foiling here. We have to FOIL the numerator and we have to FOIL in the denominator, all right? So lots of foiling. First times first, 2 times 1 is 2. Outside is 2 times -3I, which is -6I. Inside, -7I times 1 is -7I. And last times last is positive 21i squared, which I'm going to go ahead and change, all right? Positive 21i squared is going to change to negative 21. Why? I squared is negative 1. So 21 times negative 1 is negative 21. So you can do that. That is absolutely something you can do to kind of keep it simple. Do something in your head as easy as changing the sign. That's easy to do. All right, in the denominator, first times first. 1 times 1 is 1. The outside, 1 times negative 3i is negative 3i. The inside, 3i times 1 is positive 3i. And last times last, positive 3i times negative 3i is negative 9i squared. Again, I'm writing it down so you can see it in the notes, but I'm going to go ahead and convert that. Negative 9i squared. Negative 9 times negative 1 becomes positive 9. Okay, so cleaning it up, doing it in my head, well, sort of quasi in my head and on paper, totally fine to do. Let's clean up the numerator. 2 minus 21 is negative 19. And negative 6i and negative 7i is negative 13i. In the denominator, lots of cleanup. Negative 3i and positive 3i is 0. And we have 1 plus 9 is 10. And this is a fantastic answer. And it is also equivalent to say negative 19 tenths minus 13 tenths I. And I kind of like this answer best. But this is also totally okay. All right. Either one. I just like to remind you that this 10 divides both terms because that helps if you needed to reduce. Then it's easier to reduce these fractions. Okay. So always, always, always look to see if you can reduce. Question mark, question mark. That's why I really like separating it because then you can see if this was 18 tenths, that would be reducible. So you would want to reduce that. If this was 14 tenths, you could reduce that fraction. So divide and conquer, ladies and gentlemen. I really encourage this form right here is the best. Okay, so that's it for that, ladies and gentlemen. Keep these notes handy because you will definitely need them working on I.5, okay? Have a great day.